Hi guys, so today is March 25th. So I'm going to put the date here, 325. And what we're going to talk about today is what's called separable differential equations, okay? So we've done differential equations earlier, okay? And now they're a special type called separable differential equations, okay? So if the differential equation dy over dx is equal to xy squared and y equals 1, when x equals 1, find the y, okay? So what we need to do is I'm going to rewrite this, okay? And I'll explain in a minute why this is called a separable differential equation. So dy over dx is equivalent to x squared y squared, okay? And what we want to do on these separable differential equations is we want to get any term with y on the same side as dy and any term with x on the same side as dx, okay? So I'm going to multiply both sides by dx, okay? So then this would be dy would be equivalent to x squared y squared dx, okay? And we're going to integrate both sides, okay? But before we integrate, I need to get this y over here onto this other side because I need to integrate, I need y's with dy's and x's with dx. And when it's a product like this, we're going to be able to do this, okay? So separable differential equations will be a product, okay, always. And what you'll be able to do is get your y terms on one side and then your x values on the other side, okay? So what I want to do is multiply both sides by 1 over y squared. So we get 1 over y squared dy is equivalent to x squared dx, okay? And then we're going to integrate both sides. So we're going to integrate 1 over y squared dy is equal to the integral of x squared dx. Now 1 over y squared can be rewritten. So this would be the integral of y to the negative 2 dy is equal to the integral of x squared dx. And these are indefinite integrals, so we're going to pick up that constant, okay? These aren't definite integrals where we have a lower limit and upper limit like we did the other day, okay? I'm going to slide this up a little bit, okay? So the integral of y to the negative 2, we need to add 1 to the power. So adding 1 to negative 2 would give us negative 1. So this would be y to the negative 1 over negative 1, that new power, plus a constant. Now I'm going to hold off on writing that. There is a constant here, but I'm going to actually move it to the other side and make it one big constant on this right-hand side. So this is going to equal then, and then this side right here will be x cubed over 3. Okay, and then plus your constant. So this constant that was on the left side is going to be combined with a constant on the right-hand side to make one constant right here, okay? All right, now this actually becomes, okay, this is dividing by negative 1, so that's negative y to the negative 1, or negative 1 over y is equal to x cubed over 3 plus your constant, okay? So now what I'm going to do is I'm going to find my c value right now, okay? There's different ways you can do this, okay? One way is to plug in right here, because we know when this y right here is 1, the x is also 1. So this x and this y are both 1 at the same time. And that will allow us to find this constant c, okay? So I'm going to substitute those values in. So this would be negative 1 over 1 is equal to 1 cubed over 3 plus c, okay? So the left side is just negative 1 is equal to, and then this would be 1/3 plus c. Okay, I'm going to move the negative 1 to the other side. So that'd be negative, not negative 1, sorry. I'm going to move the 1/3 to the other side. So that'd be negative 1 minus 1/3 is equal to c. Now negative 1 can be also written as negative 3/3. So this would be negative 3/3 minus 1/3 is equal to c. So that's negative 4/3 is equal to c. So there's my constant now. Okay, so now we have what we have, and I'm going to come back up a little bit. Okay, what we have is let me slide. What we have is -1 over y. And so I'm going to write that right here. We have -1 over y is equal to x cubed over 3 plus your, let me slide this down a little bit more, plus your constant c, okay? So our c is negative, so we're going to write minus 4/3. Okay, so this is -1 over y is equal to x cubed minus 4 all over 3. Okay, so now it said at the very beginning, find y, right? Find y, find y, okay? So what we can do is multiply both sides by by 3 and y. So I'm going to multiply both sides by 3y. Because that will clear out the fractions. Okay, so when I multiply, I would just multiply the y's and they're going to cancel, and you're left with -3 is equal to, and then over here, the 3's are going to cancel, and you're going to be left with y times x cubed minus 4. And now because we're multiplying y by x cubed minus 4, I can just divide by the x cubed minus 4, and that would give me -3 over x cubed minus 4, and that would equal my y value, okay? So now we need to talk about something else. We got to talk about the domain. Remember we talked about the domain, okay? So what are the restrictions? What are the restrictions on the differential equation? So our differential equation was x squared y squared. Well, there's no restrictions on this. Like there's no variables in the denominator. It's not a logarithm. It's not an even root or anything like that. So there's no restrictions. But when we go to y, there are restrictions, right? Because this denominator can't be 0. Okay, so we have, what we have is x cubed minus 4. That can't be 0, okay? Which means x cubed cannot be 4, which means x cannot be the cube root of 4. Okay, so that's the only x value that we cannot use, okay? It can't be that. So that means what x values can we use, all right? So it would be -infinity to the cube root of 4, and then union in the cube root of 4 to infinity. Now, if you recall from when we first did these, okay, it can't be both of these, okay? It's only the interval that contains, our initial conditions. So these are our initial conditions right here, right? The x equals 1 and y equals 1. These are x values. So x has to be 1. And so where is x equals 1? Is it in -infinity to the cube root of 4 or the cube root of 4 to infinity? Where is 1 in all that, okay? Well, it might help to recall that, okay, the cube root of 1 is 1, and the cube root of 8 is 2, okay? So the cube root of 4, this cube root of 4 is somewhere between 1 and 2, okay? So this number right here is bigger than 1 because it has to be between 1 and 2, okay? Because it's cube root of 4, and cube root of 4 would be somewhere in between these two, okay? So that means that the domain restriction has to be this interval right here, -infinity to the cube root of 4. So our final answer would be this, okay? We have y is equal to -3 over x cubed minus 4, and its domain would be -infinity to the cube root of 4, not including, okay? And that would be our answer to this separable differential equation. I'm going to box these. Okay? All right, so that's how you do our first one, okay? All right. All right, for this next example, example 2, if dy over dx is equal to 5y and y equals 3 when x equals 0, find y, okay? So dy over dx is equal to this 5y, so that would mean dy is equal to 5y dx. So I multiply both sides by dx, okay? And then the next thing I can do is multiply, because remember, I want to get the y term by itself, right? So I want to get, or not the y, I want to get the y's and dy's on the same side. So this y right here, what I want to do is multiply both sides by 1 over y. So this becomes 1 over y dy is equal to 5 dx. And then I'll be able to integrate both sides. And I'll do that. So integrate 1 over y dy is equal to the integral of 5 dx. Okay, so what's the integral of 1 over y? Well, that's one we should recognize, okay? It's the natural log of the absolute value of the denominator here, which is y, is equal to, and there's a plus c again here, but again, I'm going to add it to the c on the right-hand side to make 1c, okay? Now, this 5 becomes 5x plus your constant from both sides, and that's your c right there, okay? So now at this point, okay, there's a couple things you can do. You can start solving for y, or you can plug in your initial conditions to get this c. You could do it either way. I like, on a problem like this, I like to solve for y first and then and then figure out what the constant c is, okay? All right, so how would we do this if we were solving for y? Okay, so we want to get to the y by itself. Well, before I get to the y, I got to get to the absolute value of y. So I have to undo this natural log. And how I'm going to do that is to exponentiate, okay? And the base that will undo this is base e. So I'm going to take e and raise it to the natural log of the absolute value of y. And that's going to equal e to this. And this is going to be the power here. The power is going to be 5x plus c. Okay, and then this left-hand side, e to the natural log of the absolute value of y, well, e to the natural log, they're going to undo each other, and you're going to be left with the absolute value of y is equal to, okay, now, this can be rewritten, okay? So when do you add these exponents, all right? So if you have something like this, x to the a times x to the b, that would be x to the a plus b power, right? That's just an exponent rule. Okay, so I'm going to use this fact that I have this, I'm going to be able to rewrite it like this, okay? So what this becomes is e to the 5x times e to the c. All right. Now, the next thing we're going to do is I'm going to make this e is a base as a constant and c is a constant. So I'm going to make this a little bit simpler on us by just calling this a different constant, okay? So I'm going to say, and you would need to state this, let k, and it wouldn't have to be k, you could call it capital A or something else, okay? But let k equal e to the c. So I'm going to replace this with k. And so I'm multiplying e to the 5x times k. I'm actually going to multiply the k on the front side of it, okay? So this becomes the absolute value of y is equal to k e to the 5x. This is going to make it a little bit simpler, okay? All right. Now, the next thing we're going to do is when we take the absolute value of y equals k to the e to the k times e to the 5x, all right, that would mean y can either equal the positive of this or the negative of it. Okay, that's just solving absolute value equations. So this is plus or minus k e to the 5x. I'm going to slide it up a little bit. Okay, so now what I'm going to do is I'm going to put in my initial conditions, okay? So I knew that y equals 3. This y right here is 3 when x is 0. So y is equal to, not y, 3, right? Because we're gonna do the initial conditions now. Again, you could have done this earlier at the very beginning and see, it gets a little bit harder if you do it that way, okay? So y is 3. So 3 is equal to plus or minus k times e to the 5 times 0 power. Well, that would be e to the 0 power. So this is 3 is equal to plus or minus k e to the 0 power. But e to the 0 power is 1. So this is 3 is equal to plus or minus k, which would mean our k is equal to plus or minus 3. Okay, so that gives us two different equations, okay? So we either have y, our k is either positive 3 or negative 3. So that means y is equal to 3 e to the 5x, or y is equal to negative 3 e to the 5x. Okay, well, which one is it? Okay, so what you can do is go back and check this, and it has to give you, when we put 0 in for x, we got to get 3 out for y, because that's what the initial condition said at the very beginning, right? When x equals 0, y has to equal 3. So when we put the 3 in for y, and that's equal to 3e to the 5 times 0, right? That'd be 3 is equal to 3e to the 0. So e to the 0 is 1, so that's 3 equals 3. So this one's the one that works, right? Coming over here, we wouldn't get that. We would get 3 is equal to negative 3 e to the 5 times 0, which is 3 is equal to negative 3 e to the 0, which means 3 is equal to negative 3, which is false, right? This one's false, and this one's true. So that means it's not this equation because it doesn't give me the correct y value. Okay, so I'm going to cross this one out. Right? And what we did here is we checked using our initial condition. Okay, so right in here, we check using initial conditions. Okay, so our equation we now know is y is equal to 3 e to the 5x. What's its domain? Okay, so if you look at 5y, there's no restrictions. There's no variables in the denominator. There's no even roots. There's no logarithms, no problems. I mean, y can be anything, okay? Down here for y equals 3e to the 5x, okay? That's also, it could be anything, right? So our domain for this separable differential equation would have to be negative infinity to positive infinity because there's no restrictions that we would have to worry about. So this would be our final answer. All right. All right, for this next example, okay, example 3, I want to consider the differential equation dy over dx is equal to negative 2x over y. Let y equals f of x be a particular solution to the differential equation that passes through 0, negative 1. Okay, this is actually from an old AP exam, okay? So find y equals fx, the particular solution to the differential equation that passes through 0, negative 1, okay? So we know that dy over dx is equal to, I'm going to make the negative beyond the 2x, so negative 2x over y. All right, automatically, there's some restrictions here, okay? Y cannot be 0. So we have restrictions on y. Y cannot be 0. Okay, so we're going to solve this, and we're going to get y equals in an equation, okay? Whatever x causes the y to be 0, we cannot use. So that's going to be a restriction on x, okay? So whatever x causes y to be 0, can't use it, okay? All right, so let's start separating these, okay? So we have dy over dx, or dy, is equal to negative 2x over y dx. And then to separate these, let's multiply both sides by y to get rid of this denominator. And we get y dy is equivalent to negative 2x dx. And now what I want to do next is integrate both sides, because I've gotten my y's and dy's on one side and my x and dx is on the other side, okay? So we're going to integrate both sides. So y dy is equal to the integral of negative 2x dx. All right. And now right here, okay, when I integrate this, this is going to be y squared over 2 is equal to, okay, and this would be negative 2x squared over 2 plus some constant c. All right. Okay, what I'm going to do next is I'm going to clear out my fractions. Okay, so I'm going to multiply both sides of this by 2. Okay, so if I multiply this side by 2, I'm going to get y squared is equal to, and if I multiply this, I would need to distribute this. Now this one, I would multiply this by 2 and it would cancel with this denominator of 2. So I'd be left with negative 2x squared. Okay, and then I'd multiply the c by 2, but that would still be a constant. So I can just put plus c. It'd be 2 times this c, but it's still a constant. Okay. All right, and then the next thing I want to do is let's go ahead and figure out what this c value is, okay? So we haven't solved yet. You could solve and then figure out your c. This is an instance where I want to figure out what the c value is right now, okay? Now, what the initial conditions, they were written a little bit differently than what they were last time. Last time it said x equals and y equals, right? But this is saying the same thing because x is equal to 0 and y is equal to negative 1. So that means for this y, I'm going to put in negative 1. So negative 1 squared is equal to negative 2 times 0 squared, because our x is 0, plus c. This would be 1 is equal to, well, 0 squared is 0 times negative 2 is 0. So this right-hand side just becomes c. So c is equal to 1. All right. So that means y squared, slide it up a little bit, y squared is equal to negative 2x squared plus 1. Okay, to get rid of the square, I'm going to square root both sides. So that would be the square root of y squared is equal to the square root of negative 2x squared plus 1. The square root of y squared is the absolute value of y is equal to the square root of negative 2x squared plus 1. Okay, solving this absolute value equation, we would get y is equal to plus or minus the square root of negative 2x squared plus 1. All right, so again, here we get two different y values, right? We get y is equal to the positive square root of negative 2x squared plus 1, and y equals negative square root of negative 2x squared plus 1. So I'm going to write both of those and we're going to talk about that, okay? So y is either equal to the positive, and I'm not going to write the positive, okay? Negative 2x squared plus 1, or y is equal to negative square root of negative 2x squared plus 1, okay? Now, what's going to happen here, y is always going to be positive, right, for this one, because we're square rooting, okay? And we can never get this to be negative, okay, because we're square rooting, okay? Think about the square root function, okay? It never goes below the x-axis for the square root function. Okay, our y, okay, when we put 0 in here, our y has to come out to be negative 1. So what happens if I put 0 here? Well, I'm not going to get y equals negative 1. I'm going to get y equals to 1, okay? Over here, if x is equal to 0, and it's just checking the initial conditions again, okay? If I put 0 in here for x, okay, that's going to be 0 here. It's going to be negative square root, so it's going to be this one that works. So we're not going to use this one because y has to be negative, right? When x is 0, when x equals 0, y has to equal negative 1, right? And this is the only one that will do that. So there's our equation for y. It's going to be y is equal to negative the square root of negative 2x squared plus 1. Okay, so now we got to worry about our domain restrictions, okay? So there was a restriction originally on the differential equation. Y couldn't be 0. There's also another restriction right here, okay? So we have two things. Y cannot be 0, right? And then the other thing is this has to be positive, okay? Or it has to be greater than or equal to 0, okay? But it can't be 0 because of this one, okay? So let's figure this one out first, okay? So we have 0 is equal to negative square root of negative 2x squared plus 1, okay? I'm going to do a couple things here. I'm going to multiply both sides by negative 1 to get the square root by itself, and then I'm going to square both sides, okay? Actually, you could also square both sides, okay? So you'd wind up with 0 is equal to negative, or actually say can't equal to, okay? Negative 2x squared plus 1, okay? Because the only way for this to be 0 is if this is 0, the inside of the square root. Okay, so then I'm going to move my negative 2x squared over. So negative 2x squared cannot, it wouldn't be negative though, huh? When I move it to the other side, it becomes positive. Okay, so when I move this over, it becomes 2x squared cannot equal 1, which means x squared cannot equal 1/2, which means x cannot be plus or minus the square root of 1/2. And that would be, can't be plus or minus 1 over the square root of 2. So x cannot be plus or minus the square root of 2 over 2 in simplified form. All right, so x can't be these, okay? So that means it could be negative infinity to negative square root of 2 over 2, negative square root of 2 over 2 to positive square root of 2 over 2. This is what we have right now. Let me write this out instead of just saying negative infinity to negative square root of 2 over 2 union square root of 2 over 2, negative, right? Negative square root of 2 over 2, comma, square root of 2 over 2. And then union square root of 2 over 2 to infinity, right? Okay, because there's two x values that we can't use, okay? All right, now, which one of these is that? Okay, so where does x equals 0 land in all this? Well, it would land in this middle one, right? Okay, so that's one of the things you can look at. You can also look at it this way, okay? Negative 2x squared plus 1 is a parabola, okay? So we also have to take a look at this. Negative 2x squared plus 1 can be greater than, has to be greater than 0, because it can't be, normally we'd say greater than or equal to 0, but it can't be equal to 0 because of this restriction over here. All right, so now this is a parabola. It's a parabola that's been shifted up 1, and it's opening down. So it's going to look something like this, and it hasn't been moved left or right. So the vertex is right on the y-axis. So it's going to look something like this. Okay, and what are these values right here? Well, these are the values. These are the x-intercepts. So this would be the negative square root of 2 over 2. Comma 0. And this one right here would be the square root of 2 over 2 comma 0. All right. And where would this be positive? Well, it would be everything in between. So that's another reason, that's just an additional fact that helps us to pick this middle interval, negative square root of 2 over 2 to the square root of 2 over 2. Okay. So what's our final answer to this? Okay. Our final answer is y is equal to negative square root of negative 2x squared plus 1, and its domain is negative square root of 2 over 2, comma, the square root of 2 over 2. Okay, and that's our final answer for this, okay? Now, I want to say something, okay? What's really, really important, okay, more important than anything else is you can solve for y, okay? This domain and all these restrictions is a little piece, and sometimes it's asked on the AP exam and sometimes it's not, okay? But you're always asked to solve for y. And most of the points, a lot of times this is on the free response section, okay, to solve these separable differential equations. And a lot of times they're just asking you to solve for y. So all you have to do is get to this part right here where y is equal to negative square root of negative 2x squared plus 1. That is really the most important thing, okay? The domain is just a little extra piece, okay? All right. All right, so let me slide that up so you can see it. Okay, so y is equal to negative square root of negative 2x squared plus 1. Domain is negative square root of 2 over 2, 2 square root of 2 over 2. Okay. All right, for this final example, okay, we have the differential equation dy over dx is equal to e to the y times 3x squared minus 6x. And we have a particular solution, or we want to find the particular solution with this initial condition 1, 0. Okay, so it needs to pass through the point 1, 0. All right, so let's start with dy over dx. So dy over dx is equal to e to the y times 3x squared minus 6x. Okay, and if you look, there's no restrictions on either y or x. Okay, so because there's no variables in the denominator, there's no even roots, there's no logarithms, so you don't have to worry about any of those restrictions on domain, okay? So the next step is we want to multiply both sides by dx, so that would give us dy is equal to e to the y times 3x squared minus 6x dx. All right. Now, this is where our y term is right here, our e to the y. So we want to get rid of that. We want to move that over here with the dy. So what I'm going to do is I'm going to multiply both sides by 1 over e to the y. So 1 over e to the y dy is equivalent to, and we still need parentheses here, 3x squared minus 6x, close the parenthesis, and then dx. All right, so now, so we've separated them, right? That's one point on the free response if you just separate these variables correctly, okay? And so the next thing I want to do is I want to integrate. So I want to integrate both sides. So 1 over e to the y dy is equal to the integral of, okay, now because I have the integral, I don't need the parentheses, okay? So 3x squared minus 6x. If you leave them, that'd be fine, okay? But everything, how you read this is everything between the integral and the dx is what you're integrating, okay? This needs to be rewritten. So this is the integral of e to the negative y dy. Why? Because I know how to integrate e to a power, okay? And then this is equal to the integral of 3x squared minus 6x dx. All right, so some of you can do this in your head, and then some of you need to do a u substitution. I'm going to go ahead and show you the u substitution because we know how to integrate e to the x, all right, or e to the u, all right? This isn't e to the u, this is e to the negative y. But if we let u equal negative y, then du would be negative 1 dy. And then this becomes e to the u, and we're going to be able to integrate it. All right. Now, we need a negative 1 dy here, right? So if I multiply by negative 1 and also multiply by negative 1 dy, I'll actually still have just dy. Okay, so this becomes the integral of e to the negative y times negative 1 times negative 1 dy. And that's going to be equal to the integral of 3x squared minus 6x dx. Okay, so this part right here is my du, this is going to be e to the u. So this -1 right here needs to come out in front. So this becomes -1, the integral of e to the u du is equal to the integral of 3x squared minus 6x dx. I have closed captioning on this, okay? And if you look at YouTube, okay, and the closed captioning is getting in your way, okay, you can just go down to the bottom right of your screen on YouTube and just click on the CC and you can turn off the closed captioning, okay? All right, so this becomes -1, and the integral of e to the u would be just -1 e to the u, or negative e to the u, is equal to 3x cubed over 3 minus 6x squared over 2 plus c. And then that u gets changed back to what it is, which is -y. So we always need to, when we do these indefinite integrals, we need to switch the u's back to y's. Not like what we do in definite integrals where we change the lower limit and upper limit to u values and we don't need to switch back, okay? These we need to switch back, okay? So this would be -1, or just negative e to the -y is equal to, well, here your 3's cancel out. So you're left with x cubed minus 3x squared plus your c. All right, so now you could either solve for y or put in your initial conditions, okay? On this one, I'm gonna put in my initial conditions. So I know x equals 1 when y equals 0, all right? X equals 1 when y equals 0. So I'm gonna come back up, slide my paper up a little bit, okay? I know you guys should be able to see this on your paper, okay? I know you can't see it right now on the screen, all right? But what we have is negative e to the -0, or that would just be 0 power, is equivalent to 1 cubed minus 3 times 1 squared plus your c. So e to the 0 is 1, so this left-hand side becomes -1, is equal to 1 minus 3 plus c. So that'd be -1 is equal to -2 plus c. And adding 2 to both sides, and I get 1 is equal to c. All right, so now what I know is that negative e to the -y is equal to x cubed minus 3x squared plus c. And now I need, no, not plus c. We figured out what c is, right? Plus 1. Plus 1. All right. So now what I want to do is I want to solve this for the y, right? For the y. So what I want to do first is I want to get rid of this negative, okay? So I'm going to multiply both sides by -1. So if I multiply this side by -1, that's going to give me e to the -y is equal to, and then this is going to, what's going to happen is all the signs are going to change. So it becomes -x cubed plus 3x squared minus 1. Okay, I'm trying to get to this y, right? So to get to that y, I need to take the natural log of both sides. And why the natural log? Because I'm using base e. So this is the natural log of e to the -y is equal to the natural log of, and then -x cubed plus 3x squared minus 1. And then natural log of e to the -y, natural log undoes e. So this becomes -y is equal to the natural log of -x cubed plus 3x squared minus 1. Now, how do we solve this for y? Well, multiply both sides by -1. So y is equal to negative natural log of -x cubed plus 3x squared minus 1. All right, now, are there restrictions on this? Okay, so that's my particular solution to this. It's y equals negative natural log of -x cubed plus 3x squared minus 1. All right, are there any restrictions on this? Yes, there are. I'm not going to worry about them here, but what you'd have to do, and this is where like this one's too difficult for the level we're at, okay? And we'd have to solve this inequality, because natural log, this has to be greater than 0. So the negative x cubed plus 3x squared minus 1, negative x cubed plus 3x squared minus 1 would have to be greater than 0, okay? And because it's a cubic, this is just going to take a long time to solve. It takes and like this is a question where they would ask you for the particular solution, but they would never ask you for the domain for the differential equation, okay? So really all our answer is this for this problem, okay, is negative natural log of negative x cubed plus 3x squared minus 1. And I just wanted to show you one that was a little more difficult than the other ones we've done, okay? And so this is our answer. And we would need to solve this inequality to get the domain for it. And we're just not going to deal with that, something that difficult, okay? All right, so you guys take care. The next thing is I'm going to show you the assignment sheet. Okay, so once again, this assignment sheet is more for me than you guys, but okay, so what I want you to do is page 361, 1 through 10, all, okay, and we did this on the 25th of March. All right, you guys take care. I'll see you next time, okay?